Good day, everyone, and welcome to the 21st edition of Group Exhibit, Hydrogen, Fuel Cells, and Batteries. I invite you to come and have a seat. Drinks are on the house. Ladies will come around and give you coffee. Time to wake up after a big meal. My name is Marie-Hélène Nieb, and I have the great opportunity today to discuss green hydrogen market approach and focus on McPhy key installation. Please help me welcome Tristan Kretschmer, their Cell Germany at McPhy. Thank you for joining us.
Thank you for having me.
So as the title says on the board, it says green hydrogen. What is green hydrogen?
Green hydrogen is basically hydrogen which has been produced via renewable energies like wind or solar power.
Okay, and what would be McPhy market approach to those green energies or hydrogen?
Well, we believe that hydrogen will play a key role in the future energy supply, and therefore we need to get more independent from fossil fuels, and therefore we need to focus more and more on the renewable energies. Also, since fossils are ending at some point of time, it is important to be more independent from those energy basics.
So that being your market approach, going away from fossil fuel, getting renewable energy. So what kind of product does McPhy offer towards harvesting those renewable energies?
We basically have two products in our range. One is the hydrogen electrolyzers via alkaline electrolyzers to produce the gas from renewable energy and water, and the other product is the storage of hydrogen via systems.
So if we focus first on the electrolyzers, what kind of range are you offering?
We have the big advantage that we purchased two companies in 2013, which were already pretty well established in the market, and therefore we have a wide range of electrolyzers. So we start from 1 normal cubic meter production units up to several hundreds of normal cubic meters per hour, meaning we can support customers from laboratories and just small units up to industrial sites.
And what if we needed to go greater than the 100 cubic meters?
Well, that was something we faced as well. It was a challenge, but we believe that it's actually quite simple answer to that question by just modularizing the systems, meaning we have modular designs of our electrolyzers that enables the customer to just add another module if more hydrogen is needed or more energy supply is just there.
And I would say that one of the great advantages to start maybe a little bit smaller and modular is the whole idea about, well, we need the infrastructure first of the hydrogen to let this market explode, etc. But if you put too big of an infrastructure ahead, there's a lot of costs associated with that.
Exactly. There was sometimes the issue customer were facing. They thought, okay, we want to invest in this technology and we want to build up infrastructure, for example, in Germany. But the issue is that if I purchase an electrolyzer of this size right now, I can use it like 20% of its capacity without gaining any or without creating any business model. And therefore we thought, okay, it makes more sense to make like a slight market approach, enable the customer to purchase, let's say, one module to feed the market on the current requirements, and then just scale up when it's needed.
So the whole idea, if we think about a refueling station, for instance, we're in a certain city and there's maybe 1 or 2 fuel cell cars.
That is, it's hard to create a business case out of this. Yeah,
exactly.
That's right.
So you can go to a smaller unit like what McPhy proposes, and then as the growth, as let's say we add a fuel cell bus, we can modularly scale.
Exactly. We can easily extend the existing system buy more electrolyzer stacks and therefore meet the future requirements and future demands when, for example, a bus comes in as well.
So it would be true to say that McPhy puts a lot of emphasis in their engineering to ensure
Right.
that the product is modular.
Exactly, yeah.
And just a few minutes ago, you mentioned acquisition in 2013. Can you give us more details about those acquisitions?
Sure. So McPhy was founded in 2008 in France. The basic idea was to create a new system to store hydrogen on a smaller footprint and with a higher energy density. So our founders created the solid-state storage. We are still holding patents on that, I think 13 patents on the technology. And in 2012, 2013, we realized that the technology is great and everything, but the customer, the whole topic is very complex, and the customer wants a fully integrated system. And therefore, we decided to purchase electrolyzers companies which are already on the market, which gained already a lot of knowledge in this technology to, let's say, fulfill the portfolio and to offer fully integrated systems for generating the gas and storing the gas. So in 2013, we took over the former PL, which is an electrolysis company from Italy. They've been on the market for 18 years, I think. And in the same year, we purchased the former Enertruck Hightech. So we took over the whole team and implemented them in our company and opened the German branch, where they are still located, where I'm still located, and where we designed the huge projects. So with this, we cover the small electrolysis via the former Italian colleagues from Peel. And for the larger scale electrolysis, we have the German project team, which designs the largest plants. And
So basically, the whole idea was to merge this expertise to create
Exactly.
one place, one-stop shop.
Exactly, and this is what's currently happening. So we kind of transfer the know-how from Italy to Germany and back and forth to optimize, first of all, the production, to optimize the smaller Peel plants, and to learn from Peel how they have been able to survive like 18 years in this market and have been so successful, because Peel alone has implemented over 2,800 electrolyzers in the market before.
So it's a fairly recent merger. It's in 2013 or acquisition. Would you say that already you can see big results from this merging of expertise?
Yes, we learned a lot from each other, and we were able to enhance our systems and make another step with the electrolysis components we are currently building, and we are currently merging in the market. So we are part of a consortium at Berlin Airport in Germany. We are part of the project calling the Multi-Energy Refueling Station, where we can display and show what we have learned so far and what we have realized during this partnership.
I want to touch base a little bit more about this Berlin project, but just before I do so, I want to remind everybody that this is a public forum, so you're more than welcome to ask questions. Just raise your hand and I'll come down with a microphone. Questions are always welcome. And to come back on that Berlin project, is it a funded project?
It is a funded project. We got fundings by the NIP. For us, it was important because under the flag of McPhy, there hasn't been so many activities by then. It was 2012, 2013 when we joined the project, and we knew that we needed to show that we are able to meet the market's requirements, and therefore we joined the project together with Linde, Total, and 2G Energy to join forces and to show and display what our technology is able to do.
So you're basically using this project as a basis to demonstrate the maturity of your products.
Exactly. We implemented a 0.5 megawatt electrolyzer, which gets feed from the grid, from the electricity grid, and we produce 100 normal cubic meters of hydrogen per hour in a very high quality. And we also implemented one of our solid-state storages to display in this consortium that our technology is mature and ready for the market.
And this project is live now, is that correct?
Yeah, it is live. Everybody is free to contact me. I'm pleased to show you around. So there's actually technology you can put your hands on. Maybe not on the electrolyzer, but yeah.
And what is the hydrogen, if the project is live in Berlin, so what is the hydrogen used for?
The idea of this multi-energy refueling station is to show and display the whole life cycle of hydrogen. So we produce it on site, we store it on site, and then we utilize the hydrogen in different ways. One idea is, for example, also to put the produced hydrogen into the gas grid. This is not realized yet, but we are discussing this. What we currently do is we use the hydrogen on site to refuel hydrogen fuel cell cars and buses, and we also feed combined heat and power system from 2G Energy, which therefore generates heat and power and feeds the whole refueling station and the car wash system.
So there's quite a few applications that your electrolyzer in Berlin is being used for, like you just mentioned. And I'd like to know, what did you most gain from this demonstration project in a technical way?
Clearly, the dynamics of the system, because this is one thing which is very important in this in our times. I mean, we have more and more renewable energies, and therefore more and more volatile energy input in the grid, and we have to stabilize the grid, and therefore systems like our electrolyzer needs to be very good in dynamics, and has to react really fast on different currents in the input. So we show currently that the system is able to follow wind profiles, meaning renewable energy.
You basically did stress analysis.
Yes.
And the data you were just saying is good?
Yes, it is good. We are very satisfied.
And what would be the next step then? So this project was started in 2012. Now the electrolyzer put it into function in 2014.
Right.
So far, the electrolyzing data says that, yeah, you can follow wind pattern. It's good. What's the next step?
Well, the next step is well, this was the very first electrolyzer of its kind. So the next step would be...
What do you mean by first?
It was, okay. So it was the first electrolyzer of its kind because it was the first electrolyzer we designed, engineered, and built under the flag of McPhy. And we re-innovated a little bit the whole design. So it is very compact. It's all mounted on one skid, which makes it easy to install, makes it easy to handle for the customer. And now we learned a lot regarding how to assemble the whole process, the whole components, and now of course we can go on larger scale for the production unit and therefore reduce costs. And I think there is still we still have some options to optimize the whole system itself. Yeah, and this is what we learned from this project. It is a pilot project.
Oh, for sure. But there's another project I want to talk about because we'll only about have 5 minutes left, and I want to make sure we get to talk about that one. You have a project in Italy.
Yeah, right. So, I mean, as I said, for the Berlin project, we focus on the electrolyzer, but of course there's also the storage, the solid storage. But this is just 100 kilogram storage. And we wanted to display that the storage system is also mature and can meet the market requirements. So we are part of a project called Ingrid in Italy, and we will install by September this year 1,000 kilogram of hydrogen storage in a solid form.
So when you say solid form of hydrogen storage, please enlighten me. What does that mean? Yeah, so the typical or general storage system is a gaseous storing of hydrogen or liquid storage system, and we use a special metal powder which involves a lot of nanotechnology to store the hydrogen within the molecules and the molecular pattern of the metal, which makes it very safe. And we learned that we can store a very huge amount of hydrogen on our footprint. So it becomes very interesting for, let's say, urban areas or areas where, gaseous tanks are not very seen and stuff like this. And this storage technology enables us to store hydrogen even on locations where usual gaseous or conventional gaseous storage systems are not allowed. So conventional hydrogen storage would be in tanks, right, under pressure, which often has brought up some safety concerns, and exactly. You're basically bringing an alternative where you're storing the hydrogen in a metallic powder.
Exactly, yeah.
And other than the safety aspect, would there be another advantage to this product?
Clearly the footprint. So we are able to store a lot of energy on a very small footprint. So we have, I don't have the factor in mind, but I think it's a factor 3 regarding to conventional gas storages. I mean, we store 3 times the same amount of hydrogen on this
on the
footprint.
Smaller volume.
Yeah, exactly.
So, okay, that sounds all amazing. We're storing 3 times as much hydrogen into the same volume in a metallic powder. The question now, how do I get it out? I have all this energy stored, but how do I get it out?
Yeah, I can't get too much into details, but it's basically just an adjustment of the environmental conditions. So to get the hydrogen in, to make the powder act like a foam and to absorb this hydrogen, we had to add a little bit of pressure and adjust a little bit the temperature. Then it's an exothermical reaction. And to release the hydrogen, we need to get some energy back, but this is all controllable. And I mean, endothermical reactions, you have to take care of the energy consumption, because you can easily decrease your efficiency, but we manage this by temperature control, and therefore we reached an efficiency with the new models of over 90%. 90%.
I just want to remind everybody, this is a public forum. Feel free, if you have any question, I'll come down with a microphone. But before I let you go, because we're running out of time here,
Right.
I have one more question for you. So you mentioned that one of the possibility, the efficiency and things like that, but you have another project also with metallic powder to store hydrogen with JVK, I believe.
JKN. Yes, thank you. Yeah, well, as I said, we gained a lot of knowledge in this technology, but we realized that it makes sense to bring in a global player who has gained a lot of knowledge and is already on the market for quite a few years. And our partner GKN, very reliable and big partner, is one of the market leaders in pulver metallurgy, and therefore we started a collaboration with GKN last year to, let's say, speed up a little bit the development of our storage systems. We have been in a pilot phase last year, and I think we will be very successful with the partnership with GKN to be cost competitive and energy efficient on the market in comparison to the gas storage systems.
Are you saying energy efficient here? So can you tell us what you mean by that?
It means that as I mentioned, if you store the hydrogen in a solid form, it is an exothermical reaction, and therefore you lose some energy. And you can control this, but we by ourselves, we gained a lot of knowledge, but we realized that maybe someone who does this for decades on the market can give us some viable input, and GKN did this. So they helped us to create a new metal powder, which is easier to control and which is very, very energy efficient, which brings us to the point to reach an energy efficiency of 92%.
So that's great news.
It is, yes.
And if any of you would like to learn more about these solid form of hydrogen storage, I invite you to go see their booth, which is located at D70, which is just right behind us.
Just around the corner.
There'll be people there more than happy to answer any of your questions. I want to thank you, the public, for your time, as well as you, Mr. Kretschmer. Thank you very much.
Thanks.
And please stay by, because we have more coming up. We'll be discussing with Valiant fuel cell heating appliances, the next generation. Stay tuned. We'll be right back. Thank you for your attention.